Hello everyone, welcome back. In today's presentation, we're going to talk about packages and libraries in VHDL. They are a nice way of organizing and structuring VHDL code that we write to describe functions, procedures, types, define types, constants, components that we want to do once, keep them in these packages and libraries nicely organized, and include them in our new projects as many times as we want, and make use of all of those utilities and definitions. It's a neat way of organizing and putting order and structure in our VHDL development, essentially. So packages basically represent collections of definitions, constants, and data types, components, and sub programs, which will include in libraries. Whenever we want to use those definitions and things from those packages, we'll have to include them in our VHDL code using this statement like this. I use clause to specify the library, which by default is called work, and a package name like a project package in this example. Libraries represent collections of compiled design units and packages, basically. And by default, the name of the library is called work, but as I'll show you later on, we can change that and create libraries with names that we want. Main takeaway is that the libraries represent the containers where we place all of this compiled components and packages in our work in VHDL. As a first example here, I have to illustrate how one needs to declare and then describe the body of a package. So there is a certain syntax and format illustrated here for a simple package called my underscore package that has just a function and the procedure. You have to end with end package, my underscore package. The body of the package doesn't show here the detailed descriptions of those functions to keep it short and simple, but I'm showing here how exactly one would need to use these definitions and functions from that package. We have to say use work that my package that all, and then here in this entity the description inside this architecture, I'm using twice that add for underscore function. That is. I have another example here where I'm trying to illustrate and show the steps of creating a library with a package, and then use that for running a simulation test bench. Let's assume that I want to create a library that I will call Chris library. So for that, I'm gonna go and start the Intel Questa simulator, and I'm gonna start it, launch it with run as an administrator to be able to create folders and place files in the C partition of my disk. But to create a library, I'll just say and go to file here and say new library. I'm gonna call it Chris library, and I'm gonna place this actually right here in the installation directory of the Intel Altera Quartus, so that I will place everything that is in my library in one single place. So let me specify that is my library like so. I have it created. Now it's empty. I'm gonna go and take a package, ALU pack.vhd, and place it there. And then I will have to go and compile, call this, of course, Chris library, and select that, compile, and done. Once this is done, you will see here that the Chris library would have that ALU package included. So that's how I created this library that has just one VHDL file, the ALU pack. All right, now I want to create a project in the simulator to simulate a test bench that uses files that make use of that library that I just created. So let me go and create first a folder with the name of that project that I want to create, and then go and bring the ALU and the test bench. Those are the design entity and the test bench VHDL files. Place them in that project folder, and then go here and say new project, go and browse. I want to go to that location where I have that inside the sandbox quest. I just created this package as example 2, which is my project. Select that, project name packages underscore example 2. I'll keep the default library name work, but I will show you that I'm using the other library as well that I created. Okay, add existing files, add those 2 files that I just placed in there, and say okay, at this point I have created the project, the test bench itself, as well as the ALU, the design entity, make use of things that I had in that ALU package that is now part of the Chris library that we created earlier. To be able to use that, I had to say library Chris underscore library as well, and that's that's like so here in the test bench itself. So that is how you would have to do to include the library and use stuff from those packages. For this test bench simulation, I will just say compile all. Everything is fine, and then just start the simulation of that test bench. Let's add all the signals to the waveform. Run it for, I know that it should be, I think, for 2600 nanoseconds, and run simulation, and you'll see simulation. We don't have time. I don't want to spend on simulation test benches. We covered that in a different video that we had before. What I wanted to show is that one can create libraries and with packages and with names that you would want, place them in some location where you always put stuff that you want to collect and create your own collection of packages and the libraries, and use them as many times as you want in all your projects, like so. In conclusion, main takeaways. are libraries represent, we could think of them as containers, places, folders, where we store all the entities, architectures, packages, all the definitions that we want to reuse while coding in VHDL. Packages are the files that contain all of those detailed information about constants, data types, and so on and so forth. So packages and libraries are really useful at organizing our work in VHDL. They help us bring structure, good organization, clean coding, basically a perfect example of code reuse. That is all. I'll see you next time.